Somewhere around Jupiter right now, a moon that should be dead is glowing white hot from the inside out. Another moon, locked in ice for billions of years, may be hiding an ocean twice the size of every sea on Earth combined. And NASA just found a reason to doubt it can support life after all. This is not a story that ends neatly. It is a story that keeps rewriting itself every few months. Because every time a NASA spacecraft gets close enough to look, what it finds contradicts what scientists thought they understood the year before. And the strangest part is this: the more powerful our instruments become, the less certain we are about what is actually happening beneath the surface of these four ancient worlds. For centuries, Jupiter's largest moons were just points of light. Galileo Galilei spotted them in January 1610, and they became the first moons ever discovered beyond Earth. A discovery so radical at the time that it helped dismantle the idea that everything in the heavens revolved around us. Jupiter's four largest moons were the first moons discovered beyond Earth: Io, Europa, Ganymede, and Callisto. For 400 years, they sat in our telescopes as little more than dots. Then, spacecraft started arriving. And what those spacecraft found turned 4 dots of light into 4 of the strangest, most violent, most scientifically explosive worlds in the entire solar system. But here's where it gets worse. Jupiter isn't just orbited by 4 moons. According to NASA's own current tally, the planet now has 101 officially recognized moons, and that number doesn't capture the complexity of the Jovian system of moons, rings and asteroids, with thousands of small objects in orbit around the giant planet. Scientists have gotten so good at detecting these tiny objects that the International Astronomical Union had to change its own naming rules, deciding the smallest new moons will no longer receive mythological names unless they are considered scientifically significant. Read that again. We are now discovering moons faster than we can name them. Jupiter isn't a planet with a few companions. It is the center of its own miniature solar system, and we have barely begun mapping it. Let's start with the moon that should not exist the way it does: Io. It is roughly the size of Earth's own moon, sitting far too close to a planet 318 times more massive than our own world. That proximity should have crushed it into something inert and cold billions of years ago. Instead, Io is the single most volcanically active body anywhere in the solar system. More violent than Earth, more violent than Venus, more violent than anything else we have ever observed. And here is the part that should unsettle you. For over 40 years, planetary scientists could not agree on why. The dominant theory since the 1980s was that a vast, continuous ocean of molten rock sits just beneath Io's crust. A shallow, planet-wide magma ocean feeding all 400 of its known volcanoes from a single underground reservoir. It was an elegant idea. It explained the endless eruptions, the constant resurfacing, the sulfur-stained landscape that looks, from orbit, disturbingly like a diseased pizza. For 4 decades, this was simply accepted as fact. Then, NASA's Juno spacecraft flew close enough to actually check. In December 2023, and again in February 2024, Juno executed 2 extremely close flybys of Io, coming within roughly 100 kilometers of its scorched, ever-shifting surface. Juno wasn't just there to take pictures, it was measuring something almost invisible. The precise way Io's shape flexes and deforms as Jupiter's gravity stretches and compresses it during each orbit. If a global magma ocean existed, the moon would bend in one very specific way. If it didn't, the moon would bend in another. Scott Bolton, the mission's principal investigator, had spent years wondering which answer they would get. According to the findings his team published in the journal Nature in December 2024, scientists with NASA's Juno mission discovered that the volcanoes on Jupiter's moon, Io, are each likely powered by their own chamber of roiling hot magma, rather than an ocean of magma. Read that again. 44 years of assumption, overturned by a single set of gravity measurements. There is no vast underground sea of lava. There are hundreds of separate localized furnaces, each one independently powered, each one capable of erupting without warning, completely disconnected from its neighbors. Think about what that means. Io isn't one volcanic system. It's 400 individual volcanic systems, stacked together on a single, small moon, each one a self-contained bomb driven by the relentless gravitational squeezing of the largest planet in the solar system. And once researchers accepted that model, the picture that emerged was even stranger. Io's mantle appears to be mostly solid, with substantial pockets of melt, overlying a liquid core. Not a uniform ocean of fire, but something closer to a sponge, riddled with isolated pockets of magma, the way water sits inside porous rock. One researcher on the Juno team described the moon's interior in almost exactly those terms: a structure filled with pores, each one capable of holding its own molten reservoir, feeding its own volcano, on its own schedule, answering to no central system at all. And this is where everything changes. Because just weeks after that discovery reshaped our understanding of Io's interior, Juno witnessed something that had never been recorded anywhere in the solar system before. In late January 2025, Juno's infrared imager, an instrument called GIRAM, detected a hotspot in Io's southern hemisphere so intense that it completely saturated the detector. Not a normal eruption, something bigger. Alessandro Mura, a Juno co-investigator, described an event of extreme infrared radiance, a massive hotspot so strong it overwhelmed their equipment. When the team reanalyzed the data, they realized this wasn't one volcano erupting. It was several volcanoes, closely spaced, erupting in near-perfect synchrony. Here's the number that should stop you. The simultaneous eruptions covered an area of roughly 40,400 square miles, about 65,000 square kilometers, releasing energy estimated between 140 and 260 terawatts. To put that in perspective, using NASA's own comparison, this single feature emitted energy roughly 6 times greater than all the power plants on Earth combined, operating simultaneously. This is not a volcano. This is not even a volcanic field. This is the most violent volcanic event ever directly observed anywhere in our solar system. And it happened not in some ancient geological record, but live in front of an operating NASA spacecraft within the last 2 years. What most people are not seeing is what this implies structurally. A synchronized eruption across dozens of miles of terrain means something is connecting these volcanoes underground. Some network of interlinked magma reservoirs that scientists hadn't even confirmed existed until this event forced them to look. Bolton himself noted that while it's exciting to witness something that rewrites record books, an eruption of this scale is likely to leave permanent scars on the landscape. Scars researchers are now hunting for using follow-up flybys and Earth-based telescopes, trying to map exactly how much of Io's surface was reshaped in a matter of days. Io, in other words, is not settling down as it ages. It may be getting more violent, more interconnected, and more unpredictable the longer we watch it. Now turn away from the fire and look at the ice. Because if Io represents chaos, Europa represents something far more unsettling. Quiet, controlled, and possibly hiding the single most important discovery humanity could ever make. Europa is almost exactly the size of our own moon, but underneath its frozen shell, something entirely different is happening. Data, going back to NASA's Galileo mission in the 1990s, first suggested that beneath Europa's ice lies an enormous saltwater ocean. And more recent estimates suggest it may hold more than twice as much liquid water as every ocean on Earth combined. Sit with that for a second. A moon smaller than our own planet, wrapped in ice, potentially holding more liquid water than the entire surface of Earth. And it isn't just water. Scientists have also found evidence that Europa may host organic compounds and energy sources beneath its surface, the basic chemical ingredients associated with life as we understand it. This is why NASA built its largest planetary spacecraft ever specifically to study this single moon. Europa Clipper launched on October 14, 2024, aboard a SpaceX Falcon Heavy rocket, and NASA Administrator Bill Nelson called it a mission that would build on the legacy of Juno, Galileo, and Voyager before it. The spacecraft is now in the middle of an extraordinary multi-year journey, flying past Mars in February 2025 for a gravity assist, and it is scheduled to swing back past Earth in December 2026 for a second gravitational slingshot, before finally reaching Jupiter and beginning 49 close flybys of Europa, starting in April 2030. Read that again. We are still years away from Europa Clipper's actual science mission, and the moon has already started revealing secrets it wasn't even supposed to be watching for yet. Because in December 2025, while cruising through space long before it even reaches Jupiter, one of Europa Clipper's instruments made an observation nobody had planned. An instrument aboard the spacecraft captured rare ultraviolet observations of an interstellar comet at a moment when Earth-based telescopes were completely blinded by the sun. Think about what that means. A spacecraft built to study an icy moon around Jupiter ended up capturing scientifically valuable data on an object that came from outside our entire solar system, simply because it happened to be in the right position when nothing on Earth could see. This is not chaos. This is a mission already proving its value before it has even arrived at its destination. But here's where the story takes a darker turn. Because the closer scientists look at Europa, the less certain they become that it's actually habitable at all. In January 2026, a new study using updated calculations delivered a serious blow to decades of optimism. According to the analysis, Europa's seafloor may be calm, cold, and largely inactive, not the geologically active environment scientists had hoped for. This matters enormously because the leading theories for how life could survive in Europa's ocean depend on hydrothermal activity. Heat and chemical energy rising from an active seafloor, similar to the deep sea vents that support entire ecosystems here on Earth, in complete darkness with no sunlight at all. If Europa's ocean floor is instead cold and geologically dead, the engine that could power alien life in that ocean may simply not be running. And it isn't only the ocean floor raising doubts. Data pulled from NASA's Juno mission, using its close 2022 flyby of Europa when the spacecraft came within about 219 miles of the surface, has been used to re-examine the thickness of the ice shell sitting on top of that ocean. The most recent analysis places Europa's icy crust at roughly 18 miles thick, and according to scientists studying this measurement, a shell that thick could be very bad news for the search for life, because it makes it dramatically harder for any nutrients, oxygen, or surface chemistry to actually reach the ocean underneath. An ocean can exist. An ocean can even contain the right chemical ingredients. But if 18 miles of solid ice sits between that ocean and the surface, and the seafloor beneath it is cold and inactive, the two conditions life most desperately needs, energy from below and chemistry from above, may never actually meet. This is the real story that most casual coverage of Europa completely skips past. It's easy to say Europa might have life. It's much harder and much more honest to say that as NASA gathers more precise data, the picture is becoming more complicated, not simpler. What most people are not seeing is that scientific progress here doesn't always move toward a bigger, more exciting answer. Sometimes it moves toward a smaller, more sobering one. And that is exactly what's happening with Europa right now, 4 years before Europa Clipper even arrives to look directly. Now shift again, because Europa isn't the only Galilean moon hiding secrets in its ice. Ganymede, the largest moon in the entire solar system, larger even than the planet Mercury, has its own strange story to tell, and it involves light dancing above its frozen surface. Ganymede is the only moon in our solar system known to generate its own magnetic field, a small, embedded magnetosphere sitting inside Jupiter's own enormous one. That magnetic field creates something extraordinary. Auroras, glowing bands of light near Ganymede's poles, functioning almost exactly like the northern lights here on Earth. NASA spacecraft have directly observed these auroral displays, describing them as strikingly similar in appearance to Earth's own polar light shows, despite forming on a moon locked in the freezing radiation environment surrounding Jupiter. This is not a minor curiosity. A moon generating its own internally driven magnetic field, strong enough to produce visible auroras, tells scientists that something dynamic and electrically active is happening deep inside Ganymede, very possibly connected to a salty subsurface ocean of its own, layered beneath the ice in ways scientists are still working to fully map. And this is where everything connects back together, because Callisto, the outermost of the 4 Galilean moons and often dismissed as the quiet, cratered, geologically boring one, has just forced scientists to rethink that entirely. Using Juno's auroral observations, researchers detected what they describe as Callisto's elusive auroral footprint, a faint signature in Jupiter's own aurora caused by Callisto's interaction with the planet's magnetic field, similar in principle to the footprints already identified for the other Galilean moons. For years, Callisto's footprint had been the hardest to detect, its interaction with Jupiter's magnetosphere so faint it kept slipping past observation. Juno finally caught it, and now scientists are asking whether this longest quiet moon has its own hidden electrical dynamics they've been underestimating for decades. Here's the pattern hiding underneath all 4 of these individual discoveries, and it's the part that should genuinely unsettle you. Every single one of Jupiter's 4 largest moons was already believed by the mid-1990s to be scientifically understood. Io, volcanic. Europa, icy, possibly ocean-bearing. Ganymede, largest moon, magnetically active. Callisto, old, cratered, quiet. That was the textbook version. And in just the last 2 years, NASA spacecraft have overturned or seriously complicated every single one of those simple labels. Io's magma ocean, assumed for 44 years, doesn't exist, replaced by something stranger and more interconnected. Europa's habitability, assumed to be almost a foregone conclusion in public imagination, is now facing serious scientific doubt from 2 separate directions at once. Ganymede's aurora reveals internal complexity nobody fully expected from a simple ice rock moon. And Callisto, the moon everyone agreed was the boring one, just revealed a magnetic signature scientists had been missing the entire time. This is not a story about 4 settled discoveries. This is a story about 4 active, ongoing scientific arguments, all happening simultaneously, all being reshaped in real time by the same handful of spacecraft. And there's a reason this matters far beyond planetary curiosity. NASA has explicitly said that the primary goal of Europa Clipper is to determine whether conditions capable of supporting life exist beneath that ice, and mission scientists have been direct about the stakes. If the mission determines Europa is habitable, it would suggest there may be far more habitable worlds scattered across our solar system, and by extension, our galaxy, than anyone previously dared imagine. That is the size of the question sitting behind these moons. Not simply, what does Europa look like, but whether Earth's biology is a cosmic rarity, or whether the conditions for life are actually common, hiding under ice shells across dozens of moons we have barely begun to study. And this is precisely why the uncertainty matters so much right now, because we are caught in an extraordinarily strange window of time. Juno, already 8 years into its mission and repeatedly extended past its original endpoint, continues making increasingly close, increasingly risky flybys through the most intense planetary radiation. Belts in the solar system, flybys that have already rewritten our understanding of Io twice in under 18 months. Meanwhile, Europa Clipper is still years from arrival, currently drifting through the inner solar system, occasionally picking up unplanned bonus discoveries like that interstellar comet observation, but still 4 full years away from beginning the flybys it was actually built for. We are living in the gap between 2 eras of discovery, one mission finishing its work in an environment that keeps surprising it, and another mission still approaching, carrying instruments that may confirm or completely dismantle the hopeful theories currently being debated in scientific journals. Think about what happens in 2030. Only a handful of years from now, in real time, Europa Clipper will begin 49 separate close flybys of a single moon, using 9 dedicated science instruments running simultaneously on every single pass. It will attempt directly to answer the question every recent study has only been circling from a distance: is the ice shell truly 18 miles thick everywhere? Or does it vary in ways that create thin spots where surface and ocean chemistry might actually mix? Is the seafloor genuinely cold and inactive? Or did that January 2026 study only capture one incomplete piece of a much larger and more dynamic system? Every current theory, every recent study casting doubt, every optimistic model from the 1990s, all of it is about to be tested directly by a spacecraft the size of a basketball court, orbiting a world we have understood until recently, mostly through guesswork and gravitational math. And here's the part nobody can answer yet, the part that should stay with you after this ends. If Europa's ocean turns out to be sealed off, cold and lifeless beneath its ice, what does that mean for every other icy moon in the outer solar system that scientists have quietly hoped could host similar oceans, from Ganymede to Enceladus to Titan? Does one disappointing result at Europa collapse the broader theory that ice-covered ocean worlds are common sites for life across the galaxy? Or does Io's shocking 2025 eruption, a volcanic event so massive it saturated our instruments, revealing a moon far more violent and far more geologically alive than we assumed even a year earlier, tell us something else entirely: that these worlds are not finished evolving, that whatever model we build today about Io, Europa, Ganymede, or Callisto will likely be broken again within another 18 months, exactly the way it has been broken twice already. We are watching 4 ancient, frozen, fire-scarred worlds in real time, and every single one of them keeps refusing to sit still long enough for us to finish writing their story. Juno is still flying. Europa Clipper is still approaching. And somewhere out there, right now, another hotspot may already be saturating a detector nobody has looked at yet.